Hello my dear all students, this is Mad Doc. So during this session, I'm mainly focused on binomial expansions, fundamental definitions, fundamental definitions. So first of all, let's analyze what is binomial. So binomial means sum of two terms, sum of two terms. Then trinomial means sum of three terms. So if we have some powers x plus y to the power 0, x plus y to the power 2, x plus y to the power 4. Likewise, if we have integer powers, we can expand it easily. Then usual expansions, it has pattern. So during this session, I'm mainly focused on how to expand these type of binomials. And using these relations, we can get any binomial expansion according to the pattern. Okay, let's see what is that. Now you consider x plus y to the power 2, x plus y to the power 0. According to your knowledge, I know you know this one 1. X plus y to the power 1, you know x plus y. Then x plus y to the power 2, you know x squared plus 2xy plus y squared. So general way you can expand it. Then x plus y cube, you know x cube 3x squared y 3xy squared plus y cube. Then x plus y to the power 4, x to the power 4, 4x cubed y, 6x squared y squared, 4xy cubed y to the power 4. These are expansions. These are expansions. Now, when you consider these expansions, generally you can expand. If you need x plus y to the power 2, you multiply x plus y times x plus y. Similarly, x plus y cube, you can expand x plus y times x plus y times x plus y. Likewise. But here these expansions, you better remember directly. You better remember directly. Usually 0 up to 4. You better remember. Then other than that, if we need more powers, more exponents, then we can use relations, we can use these patterns to get those binomial expansions. That's the thing. Okay, let's see what are these relations. So first of all, you identify we have a triangle called Pascal triangle. Pascal triangle that has made by using numbers. So here we say 1, then here next row 1 and 1, then next row 1 plus 1 2, then corners always 1, then 1 plus 2 3, 2 plus 1 3, corners 1, 1 plus 3 4, 3 plus 3 6, 3 plus 1 4, corners 1. This triangle we call Pascal triangle. So further you can evaluate this. Let's go to another row. Here 1 plus 4 5, 10, 10, 5 and corners you put 1 and 1. This is called Pascal triangle. We use this Pascal triangle to obtain binomial coefficients. Binomial coefficients. So if you consider 1 2 1, here coefficient 1 2 1, you see here 1 2 1 pattern is there, no? 1 2 1 pattern is there. If you consider 1 3 3 1, here 1 3 3 1 pattern is there. Likewise 1 4 6 4 1, you have pattern 1 4 6 4 1. Okay, likewise you can expand. So now you go to this expansion. So it start with x plus y to the power 3. No? Now you need to start first term x, start with x to the power 3, x to the power 3. Then x power decrease in 1 by 1, x cube, x squared, x to the power 1, x to the power 0, likewise. Then y power from the 0, it increases. Y to the power 0, y to the power 1, y to the power 2, y to the power 3. X power decreasing, y power increasing. Then here coefficient 1, 3, 3, 1, you need to get from the Pascal triangle. Now if you consider any term, exponent sum will be 2 plus 1, 3. Here 3, 1 plus 2, 3, 3. Here 3, no? Then that is the pattern. Now x plus y to the power 4, You start with x to the power 4, then x power decrease in 1 by 1 up to x to the power 0. Then you start with y to the power 0, y power increases y by 1 by 1, y to the power 0, 1, 2, 3, 4. Then coefficients here 1, 4, 6, 4, 1, 1, 4, 6, 4, 1, 1, 4, 6, 4, 1. Then consider x plus y to the power 5, x plus y to the power 5 expansion. You do x to the power 5, x to the power 4, y, x to the power 3, y squared, x square y cube, x, y to the power 4, y to the power 5, so on. Then you take coefficients from Pascal triangle 1, 5, 10, 10, 5, 1. You put here 1, 5, 10, 10, 5, 1 and put plus within two terms. That's how we get binomial expansion. Binomial expansion. Then this Pascal triangle finding technique, by Pascal triangle binomial expansion technique, that is better for less powers, no? Some small powers. Then up to 6, 7, 10, it is applicable. But 100 power, 101 power, 1000 power, this is not practical way. So for that we have binomial theorem. For that we have binomial theorem. But don't worry about that for now, but you identify this pattern as binomial expansion. And one another important thing, so here some can be addition or subtraction. Therefore, if you see x plus y, x minus y, then that is 0, or less x minus y to the power 0, 1. Then here minus, then you need to change y by minus y, no? Then change only this sign. So if you get minus sign here, then you put here plus, then here minus, then here plus. Even powers won't affect to the sign, no? Then odd powers need to change the sign. Then for minus here minus, plus, minus. Odd powers you change the sign. Then here minus, here plus, then minus, plus, then minus, then plus. Then minus here, you put plus, minus, here plus, then minus, plus, then minus. So on, you can expand the binomial. So now you know how to expand binomial relations. These relations are very important when you are doing mathematics. So I have given these for x plus y or x minus y terms. But binomial can be different forms. As an example, x plus 1 to the power 4, x plus 1 over x to the power 5, then 2x minus 3y to the power 3, likewise. Then you apply this pattern when you are doing expansions. You apply this pattern when you are doing expansions. Then you identify binomial mean very important relation in mathematics. Then you need to get proper idea about these type of expansions. This is the best technique to expand some less powers of binomial expansions. But you remember, for high powers, we have binomial theorem. And here we discuss only about positive integer powers or 0 with 0. But for negative integers, but for fractions, we can write expansions, but not this method. So this is about binomial expansion. Then I know now you have good idea about binomial expansion. Thank you for watching us.